Tonight, we're looking into posts being spread on social media. They claim the James Webb Space Telescope spotted a large object about 10 light years away moving toward Earth. The posts claim that the telescope captured the object changing its trajectory in an unnatural manner, meaning it must be some sort of extraterrestrial life.
The more I look at the universe, just the less convinced I am that there is something benevolent going on.
Mysterious objects are hurtling toward Earth, prompting the United States government to go on high alert. The skies are teeming with activity as scientists race against time to determine the threat posed by these cosmic invaders. This is not some distant speculation. The danger is real, and every moment is critical. Join us as we delve into the chilling details, the ongoing efforts, and the devastating scenarios that could redefine life as we know it. Cosmic threats and survival strategies begin with Bennu, a name that should already command your attention. This asteroid, roughly 500 meters in diameter, has been the subject of intense scrutiny for years. While it's not expected to collide with Earth anytime soon, a potential impact in the 22nd century could be catastrophic. Scientists are not sitting idle. They launched the OSIRIS-REx mission to collect samples of Bennu's surface material and bring them back to Earth. Why? To uncover the secrets of its composition and behavior. Understanding Bennu could help us prepare for worst-case scenarios, whether by devising technology to divert its trajectory or fortifying against an impact. Though the odds of a collision are slim, the stakes couldn't be higher. Bennu harbors secrets that could revolutionize our understanding of near-Earth objects. Bennu isn't the only celestial body causing concern. Apophis, another asteroid, once kept scientists up at night with its potential threat. The good news is that it's not on course to hit Earth anytime soon. The bad news? It will pass alarmingly close in 2029. Scientists plan to seize this opportunity to study it up close, akin to cautiously observing a wild animal from a safe distance. This is all part of a larger initiative to monitor and understand near-Earth objects, NEOs. After all, it's better to be overprepared than underprepared. While asteroids steal the spotlight, our sun is another looming concern. This blazing sphere of nuclear fusion sustains life but also poses significant risks. Solar flares, violent eruptions on the sun's surface, can trigger geomagnetic storms on Earth. These storms can wreak havoc on satellites, GPS systems, power grids, and more. In 1989, a geomagnetic storm caused a massive power outage in Quebec, plunging millions into darkness. Imagine the consequences of a similar event today in our tech-dependent world. That's why predicting space weather has become a critical endeavor, aiming to detect solar outbursts early and mitigate their impacts. And let's not overlook rogue planets, massive, starless wanderers expelled from their home systems. These celestial drifters roam the cosmos without an anchor. While the odds of one colliding with Earth are infinitesimal, their mere existence keeps astronomers vigilant. If a rogue planet ventured too close, it could disrupt our solar system's delicate gravitational balance, potentially causing planets to deviate from their orbits. These enigmatic bodies intrigue us with questions about the universe's chaos and potential for life. Could they harbor life? Perhaps, but they're unlikely to be hospitable neighbors. Rogue planets are fascinating reminders of the cosmos's unpredictability. Picture a world adrift in eternal darkness, its temperatures plummeting to hundreds of degrees below freezing. Some scientists theorize that these planets might host subsurface oceans warmed by internal heat, raising tantalizing questions about their potential to support life. While the probability of a rogue planet crossing Earth's path is minuscule, the consequences would be devastating. Then there are black holes, the universe's ultimate enigmas. Though they're not actively targeting Earth, their gravitational pull is so immense that even light cannot escape. If one wandered too close, it could wreak havoc on the solar system, scattering planets and asteroids like toys. Thankfully, the nearest supermassive black hole is far away and relatively dormant. However, the cosmos is teeming with rogue black holes, and their unpredictable nature is a concern. Speaking of black holes, let's not forget the supermassive ones lurking at the centers of galaxies, including our Milky Way. Sagittarius, a colossal black hole at our galaxy's heart, is currently quiet, but an active one could unleash radiation with far-reaching effects. The idea of a rogue black hole entering our solar system might seem like science fiction, but the universe is full of surprises. It's better to comprehend these phenomena than to ignore them. With so many potential threats, it's easy to feel like Earth is a sitting duck. However, the reality is more nuanced. Scientists and engineers are tirelessly working to understand these dangers and devise protective measures. From tracking asteroids and forecasting solar storms to studying rogue planets, every discovery enhances our defenses. For instance, interest in planetary defense systems is growing. These technologies aim to deflect or destroy incoming asteroids before they pose a threat. NASA's Double Asteroid Redirection Test, DART, mission demonstrated the feasibility of altering an asteroid's course, marking a significant milestone in our preparedness for cosmic hazards. Revisiting Apophis, discovered in the early 2000s, this asteroid measures over 1,200 feet across, roughly the length of 3 football fields. An impact would unleash city-level destruction on an unimaginable scale. Fortunately, scientists have confirmed that Apophis won't collide with Earth during its close approach on April 13, 2029. However, it will come uncomfortably close, even closer than some satellites. Imagine gazing skyward to see a bright streak. That's Apophis, offering a once-in-a-lifetime spectacle, hopefully without disastrous consequences. Here's the catch. While 2029 is safe, Earth's gravity could alter Apophis's trajectory, creating potential risks for its next close pass in 2036. This possibility has scientists running simulations and crafting contingency plans. After all, gambling with an object capable of leveling a city is not an option. NASA has already begun conducting asteroid preparedness drills, essentially cosmic fire drills with higher stakes. A recent simulation presented a sobering scenario: an imaginary asteroid detected mere months before impact. The exercise underscored the limitations of current technology, which requires years to prepare for such threats. The logistical challenges of international collaboration further complicate matters. The lesson is clear: preparedness is crucial. This isn't just about Apophis. Countless other asteroids, some too small to detect until they're dangerously close, are out there. Remember the Chelyabinsk meteor of 2013? Despite being only 60 feet wide, it exploded over Russia with the energy of multiple nuclear bombs, injuring thousands and shattering windows. Events like these are stark reminders of our vulnerability to cosmic surprises. Scientists are trying to improve our odds. NASA's Scout system, for example, recently tracked a tiny asteroid that burned up harmlessly over Germany. That success shows progress in monitoring these space rocks, but it's still a far cry from being ready for the big ones. International cooperation is also a must. An asteroid impact wouldn't just be one country's problem, it'd be a global disaster. However, getting countries to agree on how to handle it is another story. The recent drills reveal gaps in communication, planning, and available technology. Now, a look back at the collision that changed life on Earth forever. Are we ready for another strike? 66 million years ago, something massive hurtled through space and smashed into what is now Mexico's Yucatan Peninsula. The aftermath was a cataclysmic extinction event that wiped out 75% of life on Earth, including the dinosaurs. They had ruled the planet for over 100 million years, and then, just like that, their reign ended. It's a chilling thought. Could something like this happen again? Asteroids crashing into Earth isn't science fiction. It's a fact. Impact craters scattered across the globe are evidence of these cosmic collisions. Experts like Dr. David Kring, a planetary geologist, and Dr. Mark Boslow, a physicist, study these impacts to understand their scale and implications. For example, the Chicxulub crater, a massive depression buried beneath Mexico's Gulf Coast, is thought to be about 110 miles wide. It was created by an asteroid roughly 6 miles across, like a rock the size of a city slamming into Earth at mind-boggling speeds. What happens when an asteroid hits Earth? First, it tears through the atmosphere, heating up and vaporizing as it crashes. The Chicxulub asteroid, for instance, displaced massive amounts of air, creating a plasma that radiated heat and light. The result was an explosion so intense it rivaled temperatures found on the sun's surface. Imagine rock and debris flying 60 miles into the air, 10 times the height of Mount Everest, before raining back down. Fires ignited across the globe and the skies choked with ash and dust. Then there's the water. A massive impact near an ocean triggers towering tsunamis. At Chicxulub, waves at least 300 feet high surged across the Gulf of Mexico, inundating what is now Texas and pushing inland. A wave of that scale would make skyscrapers look puny. Cities would be wiped off the map. The aftermath of an asteroid impact is nothing short of apocalyptic. The Chicxulub event ejected an estimated 10 trillion tons of debris into the atmosphere, blotting out the sun. Without sunlight, plants die, disrupting the food chain from the bottom up. Temperatures plummet, triggering an ice age. Earthquakes ripple through the crust and the ground itself shakes violently. Buildings crumble, roads disappear, and life as we know it collapses. But imagine if this scenario unfolded today. An asteroid just a few miles wide, much smaller than Chicxulub, could unleash devastation on an unimaginable scale. A direct impact near a major city would obliterate everything within a radius of hundreds of miles. The intense heat would vaporize life in mere seconds. Even smaller events, such as an airburst, could incinerate a city or cause catastrophic destruction. The most alarming aspect? Earth is constantly bombarded by space debris. Most of it is minuscule, no more than dust particles, and burns up harmlessly in the atmosphere. However, larger objects, a few meters wide or more, can penetrate the atmosphere and strike the surface. Scientists estimate that over the past 600 million years, Earth has been struck more than 60 times by objects at least 3 miles wide. The question isn't if it will happen again, but when. Efforts to monitor potential threats are underway. NASA and other organizations are tracking asteroids, but the task is monumental. Many asteroids are nearly invisible, their dark surfaces blending into the vastness of space. Current deflection plans, such as using a spacecraft to nudge an asteroid off its trajectory, remain theoretical and rely on advanced warning. Without sufficient notice, humanity would be largely powerless against a sudden impact from space. The Chicxulub event also serves as a stark reminder of Earth's vulnerability. The sulfur-rich rocks at the impact site combined with the asteroid's sulfur to create a toxic atmosphere. These gases lingered for decades, altering the climate and amplifying global warming. A similar event today would have catastrophic consequences. The resulting greenhouse effects could persist for centuries, compounding the challenges of an already fragile ecosystem. Even a smaller asteroid, just a few hundred feet across, could wreak havoc. Such impacts are far more common and could destroy cities or cause widespread devastation. With over 800,000 asteroids identified in our solar system, the odds of a significant collision are far from negligible. The message is clear. Earth is exposed. While advanced technologies and space programs provide hope, humanity must take proactive steps to prepare for the unpredictable. The massive crater at Chicxulub stands as a testament to our planet's violent history and our collective responsibility to safeguard its future. Whether through improved detection systems, global collaboration, or innovative solutions, the clock is ticking. The next major impact might not be 66 million years away. To comprehend the scale of destruction an asteroid impact could cause today, consider the ramifications beyond the immediate blast zone. The initial collision would unleash kinetic energy measured in tens of millions of megatons. For comparison, the most powerful nuclear weapons ever detonated, such as the Tsar Bomba, are measured in tens of megatons. An asteroid's energy would far surpass these. The resulting thermal radiation could ignite fires thousands of miles from the impact site, consuming forests, fields, and cities alike. The subsequent shockwave would flatten structures, uproot trees, and permanently alter the landscape. Beyond the physical destruction, the secondary effects would be equally catastrophic. Vast quantities of dust and ash ejected into the atmosphere could trigger a nuclear winter. Deprived of sunlight, global agriculture would collapse within weeks, leading to widespread famine and societal breakdown. Wildlife and marine ecosystems would be devastated as food chains disintegrate. These cascading effects would render survival nearly impossible for most species. An oceanic impact would unleash tsunamis, devastating coastlines worldwide. Waves hundreds of feet high would obliterate cities and displace millions of people. The psychological trauma for survivors, coupled with the immense logistical challenges of providing aid and rebuilding, would strain global resources to the breaking point. Long-term climatic effects would linger for decades. Reduced sunlight from atmospheric debris would lower temperatures, halting photosynthesis and triggering a chain reaction throughout ecosystems. Combined with toxic gases like sulfur dioxide, Earth's atmosphere could become significantly less hospitable for humans and other life forms. Asteroid impacts also threaten modern technology. Satellites could be damaged by debris, disrupting communication systems. Power grids and critical infrastructure might fail due to electromagnetic pulses generated by the impact. Our dependence on interconnected systems could become a significant vulnerability in such a scenario. Given these potential outcomes, planetary defense has never been more crucial. Scientists and engineers are exploring various methods to prevent or mitigate asteroid impacts. One proposed solution is the gravity tractor method, which involves positioning a spacecraft near an asteroid to gradually alter its trajectory through gravitational pull. Another idea involves deploying solar sails or rocket engines on the asteroid to nudge it off course. These strategies require precise calculations and years of preparation, emphasizing the importance of early detection. Public awareness and international collaboration are essential components of planetary defense. Governments, scientific institutions, and private organizations must work together to fund research and develop the necessary technologies. Education campaigns can help the public understand the risks and prepare for potential emergencies. Investing in asteroid detection and response systems is not merely a scientific endeavor, but a matter of global survival. How much responsibility should humanity bear for its survival against cosmic threats? Share your thoughts below, and don't forget to like, comment, and subscribe.